It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about optimization word problems. A gardener wants to fence off a rectangular vegetable patch in their backyard. One side of the patch will border an existing fence, so they only need to use new fencing for the other three sides. If they have 30 meters of new fencing available, what is the largest possible area they can enclose? Let the width of the patch, which is perpendicular to the existing fence, be denoted by X, and the length of the patch, which is parallel to the existing fence, be denoted by Y. So to answer this word problem, we need to understand clearly what the problem is all about and what we wanted to do, or what the problem wanted us to do. So first, it says here we have a gardener and he wanted to fence off the rectangular vegetable. So we have the orientation of the vegetable patch that he wanted to fence off, which is rectangular in nature. And one side of the patch there has an existing fence already. So if we are to draw or to outline our problem, if this is our rectangular patch, one side of that one is already a border on the other fence. So let's say, for example, this is our fence here, or this is another patch, perhaps that might have a fence already existing. So that means to say that we are not going to fence this portion here because it has already an existing fence. So what we're going to fence is this side here, this side, and this side here. So we only have to fence three sides of the rectangular vegetable patch. Now, according to this one as well, we have the width of the patch, which is perpendicular to the existing fence. We denote that one with an X. So if this is the existing fence here, perpendicular to that one, the one which is going to be forming an L, together with the existing fence here, that is what we denote as an X. So if this side is an X, of course, this side here is also an X. And of course, this side here is our Y. So based on that information that we have, we are going to solve the problem. And what the problem would wanted us to do is to know what is the largest possible area they can enclose, or the gardener can enclose. So meaning to say, we are trying to maximize our area. So we have here, we let our A be the area. So we're now setting our different variables. So our A there stands for the area, while our X, according to the problem there, our X is the width of the patch. And of course, we have our Y there be the length. Once we're done with our introduction of the different variables and so with the outline, we are going to know the given information. So the given information here is only 30 meters, which is the new fencing available. So that's the available material they're in. So that means to say the 30 meters there is the one that we're using for this side, and that side. So meaning to say the 30 meters there is our perimeter based on the given. And of course, since we have the perimeter there, the perimeter formula, by the way, is for the rectangular field or patch is gonna be 2x plus 2y. But then again, if you try to look at this, we are trying to fence this area, this side here, the x, the y, and so with the x. Once we say perimeter, we are actually getting the total length of the sides that we are going to fence. So basically, we're adding all the side length there. So we have there x plus y plus x, or simply 2x plus y. Replacing our perimeter value, which is 30. So we have 30 equal to 2x plus y. So this is our first equation. And another equation that we can come up with it, because once we do optimization problem, normally we're working out with two equations. So the first equation here is with the given, which is the 30 as the perimeter. And the next given here is what we wanted to optimize or to maximize, which is the area. Our area for a rectangular field or patch is simply x times y, or the length times width. And if we wanted to optimize area, that means to say we're working out with an area as a function of x. So meaning to say, since area is a function of x, all of this side here must be only containing an x. But look at this, we have our y. So we need to replace the y there by simply building from your equation 1 the value for y in terms of an x. So we move 2x to the other side by simply subtracting from this side here the 2x and also on the other side. So that means we have a 30 minus 2x. That will be equal to a y. This y here will be using that one and replace the y on our area. So we have our x times the y instead of y. We're replacing that one with a 30 minus 2x. And out from there, we can now solve or find our domain. The domain there is a set of possible values of x for your particular function. So finding the domain, we are going to set our area equal to a 0 because we wanted to solve for the value of x. So meaning to say we have here area, we replace that with a 0 equal to an x times 30 minus 2x. So out from there, we can now have, let me rewrite that. So we have 0 equal to x times 30 minus 2x. So out from there, we can now solve for our domain. We equate each of the factors here, starting off with x, equate that to a 0. And then the next factor, 30 minus 2x, equate that one to a 0. Then solve for x. So for this one, this is already x equal to 0. For this one here, we need to move our 30 to the other side by subtracting that one on this side by 30, and so with the other side. So this means we have negative 2x equal to a negative 30. We're dividing this one by a negative 2, and so with this one by negative 2, our x is equal to 15. So meaning our domain here is gonna be with an interval from a 0 to 15. So since we have now the domain, we are now ready to find the critical value. So finding the critical value, all we have to do is to simply just get the derivative of the function. Our function a while ago, we have that area in terms of x is equal to x times 30 minus 2x. To get the derivative of that, we may distribute the x here. So we have a of x that's equal to 30x minus 2x squared. Then we get the derivative of that one. So derivative of area of x, that will be equal to 30 minus 2 times 2, that will be 4, and then an x. So this is our derivative, and take note, in finding critical value, we set our derivative equal to a 0 to solve for x. We move 30 to the other side by simply subtracting 30 here and subtracting 30 on the other side. So we have negative 4x, that's equal to negative 30. We're dividing this one by negative 4 to get the value of x as the critical value. Our x there is equal to 30 over 4, or that will be equal to a 15 over 2, or that is equal to simply 7.5. So once you've got a critical value, you are going to determine whether we have here a maximum value or a minimum value by simply setting a table of values, or you may do the first derivative test. But for me, I'm going to use evaluation of function here by simply using the x value for the interval. We have the interval, the endpoint of the interval is 0. And then another endpoint there is a 15. And then, of course, we'll be using also the critical value, which is a 7.5. And then we are going to solve for our f of x. Now, the f of x will be replacing here our f by our area, because we're naming our function based on the quantity that we're representing, and that is the area. So instead of using f of x, we're using a of x. So to get the a of x value for where x is 0, we just simply utilize this one here. Or you can also use the second one, whichever is. We have the same answer for that one. So using the first one, we've got x. We replace that one with a 0 times 30 minus 2 times 0. That will be a 0. So this one is a 0. Then we go for finding another value, which is an area where x is 7.5. And then that will be equal to 7.5 times 30 minus 2 times 7.5. Inputting that one in a calculator or manually computing that one, we can see that this one here, once you multiply 2 times 7.5, that would lead to a 15. 30 minus 15, that's a 15 times 7.5. That will be equal to 112.5. So supplying that one here. So we have our area for x, which is equal to 7.5. Next one, we are going to look for the area where our x is 15. So we have this 15 times 30 minus 2 times 15, which would lead this one here, the 30 minus 2 times 15, that will be a 0, times 15, that will be a 0. So out from here, we can see that our area is maximum at 112.5. So this is our maximum, because if you try to compare that one with the different values for the area, we have this as a 0, this one as a 0, well, this one is 112.5. Automatic, that is our maximum area. So we can just simply say maximum point is with a 7.5 as our width of the rectangular patch. That will be equivalent to an area which is 112.5. And then, of course, we can conclude there, because our problem is asking us about what is the largest possible area that they can enclose. So which means that we have, so the largest, we're answering actually the problem there. So the largest possible area that they can enclose is 112.5, and then we've got the unit for the area is square meters. Let's have our next problem. We have a local theater finds that its daily profit P in Philippine peso from selling T tickets is given by the function P of T equal to negative 5T squared plus 290T minus 2,000. How many tickets should the theater sell to maximize its daily profit? So, according to the problem, we are to maximize our profit, our daily profit. With the given information on the equation to maximize with, so we're not really are in trouble here. So what we're actually doing is to really go for the maximizing problem right away. So we are going to simply find first our domain because we don't have any given interval there. So we will be finding the domain first. We don't need to introduce our variable there because we have already introduced there that the profit is represented by the P while the ticket there is the letter T. So finding the domain, so we are going to set our P of T here to 0. And that will be equal to negative 5T squared plus 290T minus 2,000. Now, noticing that all of the terms there, we've got a common factor which is 5. So we'll be factoring out negative 5 so that it will be a lot easier for us to solve for t in simply factoring it out. Yes, factoring it out. So factoring out negative 5, so we have the remaining factor will be t squared because we're dividing negative 5t squared by negative 5, so that's a positive t squared. And then we have 290t divided by negative 5. That would result to a plus 58t. And then we have minus 2,000 divided by 5. That will be a minus 40. Okay, out from there, we can just simply eliminate the negative 5 by dividing here a negative 5 entirely. Because we're working out on an equation, so we can just simply do it like that. So we have now 0 is equal to t squared plus 58t minus 40. And then we factor it out, so we have our factors, t. We're going to look for factors for, and by the way, we have factored out negative. So, of course, this will change. So, you have to be careful on that one. Otherwise, you will have an incorrect answer later on. So, since we're factoring our negative sign, we are going to change all the sign here. So, from negative 5t squared, that will become positive. From positive, that will become a negative. From negative, that will become a positive. So we have minus and a plus. So out from there, we are to look for factor for 40, in which, and by the way, this is not 40, this is actually 400. So we are going to look for factors of 400 that would lead to a negative 58. And the factor that we are to consider here is the negative 50 and negative 8. Because negative 50 and negative 8, once you're adding that one, that would lead to a negative 58. Negative 50 times negative 8, that would lead to a 400. So we are to utilize the factors, a negative 50. So we're attaching that one to our t. And then we have t minus 8. So out from there, we have now factored form equation. So we are going to equate each of the factors to a 0 to solve for t. So t minus 50 equal to a 0. The other factor there is t minus 8 equal to a 0. Our t here is equal to a 50, while the other t is equal to an 8. So identifying now the domain, our domain here is going to be starting off from 8 until 50. That will be the possible value of our t. Next one, we are going to find the critical value. So finding the critical value here, we'll start off with identifying our derivative. So p prime of t, that will be equal to, get the derivative of this first term. So negative 5 times 2, that's negative 10. And then we have a t plus derivative of this is 290. Derivative of this is a 0. So we have that one as our derivative. So once we're done with the derivative, we're equating that one to a 0. And then we are solving for t. So that means we are to move that one there on the other side. So negative 10t, that will be equal to negative 290. And then we divide this one by negative 10 to solve for t. Our t here is equal to positive 29. So this is our critical value. So we're now going to identify what is the maximum value for this one, because we are trying to maximize our profit. So finding for the maximum value here, so we are to assign the x values. Actually, it's not the x. We're using t here as our independent variable. So we'll also be utilizing our t. So instead of x, we'll use t. Okay, so out from there, we have now t will be, of course, the endpoints. So we have an 8. Another endpoint there of your domain is 50. And then we have our critical value, which is 29. So solving for p of t, p of 8, which means we are to utilize our original equation. So starting off with negative 5 times t is 8, raising that to the power of 2, and then plus 290t. Our t there will be replaced by 8 minus 2,000. This would lead to a 0 as the value. So we have that one as a 0. And then we have p of 29. That will be equal to negative 5 times 29 squared plus 290 times 29 minus 2,000. And solving for that one, that will be equal to 2,205. And then lastly, we have our p of 50. So we have that as negative 5 times 50 squared plus 290 times 50 minus 2,000. This would lead to a 0. So noticing this one is our maximum value. So we are to write there maximum point. Our maximum point there is at 29, 2,205. So answering the question on the problem, how many tickets should a theater sell to maximize its daily profit? The maximum daily profit here is 2,205. To achieve that maximum profit, we have to sell. So the theater needs to sell 29 tickets to achieve a maximum profit. So that is how you are going to solve your optimization word problem. So this is again your teacher Jenny saying practice and practice, and that will eventually lead you to perfect.